In this video, I will be talking about Google's DeepDream. So what is it? DeepDream is a computer vision program that uses convolutional neural networks to find and enhance patterns in images via algorithmic pareidolia, thus creating a dreamlike appearance from the deliberately overprocessed images. Here you can see a simple portrait of Mona Lisa. However, in this image, it seems to have been overly processed to such an extent that pretty much every part of this image seems to be like a dog. So why use Google's DeepDream? Artificial neural networks have spurred remarkable recent progress in image classification and speech recognition. Although these are very useful tools based on well-known mathematical models, our understanding of why some models work and others don't is surprisingly little. Hence, DeepDream. Although predominantly is just for fun. So how does DeepDream help in understanding an artificial neural network? We train networks by simply showing them examples of what we want them to learn, hoping that they would extract the necessary features and learn to ignore what doesn't matter. We gradually adjust the network parameters until we get the desired classification. The network usually consists of 10 or more stacked layers of artificial neurons. One of the challenges is understanding what exactly goes on at each layer. After the training, we know that each layer progressively extracts higher-level features of the image until the final layer, which decides what the image is depicting. But how do we check that the network has accurately learned the right features? Using DeepDream, you can visualize the network's representation of a particular class or a feature. So let us understand how exactly DeepDream works and how it helps us in understanding an artificial neural network. So in 2012, for the ImageNet challenge, GoogleNet was developed and released by Google, which uh, used modules of convolution layers known as inception modules. So in order to understand how the DeepDream program works, let us oversimplify it by using a multi-layer network and understand how it works. So we have our input neurons and the intermediate neurons, and then the output layer. So this particular neuron basically takes the weighted sum of these input neurons, and the same does this uh, neuron do. So what we basically do is train this particular network on a dataset, say to classify whether the image that we give as an input is a cat, a dog, or a house. So once we train this network, we get a cost function, which basically is the difference between the predicted output and the output that we basically want. And then we implement the backpropagation algorithm so that this error rate is minimized so as to ensure the accuracy of this neural network is pretty high, and then it is able to classify the input images that we give as either a cat, a dog, or a house, and the other class labels that the training dataset has. So for example, let us give an image of a cat. The first layer, it's going to look at features such as lines, edges, corners, etc. And then as we move through the neural network, as deep we go, it starts to look at much more interesting and higher level features, such as maybe in this network you might be looking at smaller objects or multiple lines, and then as we move further, in this particular layer we might see much more higher level features such as pause or the ears, or much more visual features of a cat, such as its tail, etc. And then in the end, this particular neuron lights up because um, this neuron here has predicted paws. This has predicted the image to have pointed ears. This has predicted it to have fur, and then this has predicted it to have a certain type of lines and edges. So in order to classify this as this image as a cat, the neural network follows a particular path, and then it gives us the output as a cat. This is enough to understand how a classification problem is solved. Now, in the Google Net, where the technique of inceptionism is used, about which we'll discuss later, all these neurons are basically convolutions where the features are extracted, and much more higher level features are extracted as we move further deeper into the neural network. So, what exactly do we want from Google's DeepDream? It is to basically minimize this cost function and maximize features such as this or this. Maybe uh, this depicts the feature of more cat faces. Maybe this depicts the feature of more fur, and this basically the paws of a cat. So what we're trying to do is minimize this cost function, whereas maximize these particular features by either taking their sum or the means squared sum. And then what we're trying to do is I want uh, more of cat faces, or I just want more of fur, and I just want more of the paws of a cat. So what it's going to do is when we give an image, say we have given the same Mona Lisa painting, what it's going to do is as we move further the neural network, it will start analyzing the picture and then over process it in such a way that we end up having only these features being maximized, and ending it to produce a hallucinated image with um, only the features of a cat. So, uh, by looking at these examples, I think we can understand the way Google Deep Dream works in a much better way. So, as you can see here, this is a simple image where there are two animals in a deserted forest, and then in this particular image, you can see that multiple lines and curves have formed, giving us an insight that the lower level features of a neural network have been maximized so as to for us getting this picture. And in a similar way, this is a beautiful picture which has been completely over processed, and here we find out um, small buildings are slowly forming as we continue the training process of the deep dream program. In a similar way, we can also see here the images of a cat or a dog, the eyes and nose, the scales of a fish, a lot of features that we have maximized for the particular neurons are starting to show up in these images. Similarly, here are few more examples of what Deep Dream can generate. As you can see, by using Deep Dream, we can actually generate a lot of art. So coming to the topic of inceptionism, uh, this is basically the technique that we use in Google's DeepDream. So this technique gives us a qualitative sense of the level of abstraction that a particular layer has achieved in its understanding of images. If we apply the algorithm iteratively on its own outputs and apply some zooming after each iteration, we get an endless stream of new impressions exploring a set of things that the network knows about. So, to conclude the topic of deep dreams, we can learn that apart from the fun aspect of deep dream, it helps us understand and visualize how neural networks are able to carry out difficult classification tasks, improve the architecture, and check what the network has learned during training. It also makes us wonder whether neural networks could become a tool for artists, like as we've seen in the earlier images, where beautiful hallucinations and some disturbing too have formed. Another example could be the latest model that has been released by OpenAI called as DALL-E 2, um, which actually works in favor along with Google's DeepDream to make us debate whether neural networks could become a tool for artists. Thank you.